Chapter 17. Symmetry. Introduction. Symmetry is quite a common term and also an important geometrical concept. Architects, artists, designers, and many others make use of this concept. Have you observed a butterfly? When it folds its wings, each part of one wing exactly fits on its corresponding part of the other wing. If we look at leaf, plants, and animals, we find that they have symmetrical body parts or shapes. Even human face is symmetrical in shape. The architectural marvels like Taj Mahal, India Gate, and various such buildings are beautiful because of their symmetry. The word symmetry means allowing an object to be divided into two equal halves, such that one part coincides with the other. There are many types of symmetry, such as point symmetry, line symmetry, plane symmetry, etc. In this chapter, we shall study the symmetry of figures about lines. Line of symmetry. Let us take a sheet of paper and fold it into two halves. Figure 1. Punch a hole in it. Figure 2. We open the sheet of paper and find two holes. Figure 3. Symmetrical about the fold. A symmetrical figure has a line of symmetry. If a line divides a given figure into two identical halves, then we say that given figure is symmetrical about that line. The line is called the line of symmetry or axis of symmetry. Look at these figures. Vertical line of symmetry. Vertical line of symmetry. Vertical line of symmetry. Horizontal line of symmetry. Example: are the letters A, B, D, H of English alphabets symmetrical? Solution: all the letters are symmetrical. A is vertically symmetrical, B and D are horizontally symmetrical, letter H is horizontally as well as vertically symmetrical. Example: find the number of lines of symmetry in each of the following shape. Solution: there is one line of symmetry, L, as shown in the figure. There is one line of symmetry, M, as shown in the figure. Symmetry of some geometrical figures. Let us now discuss the symmetry of some geometrical figures. Line segment. A line segment is symmetrical about its perpendicular bisector. Let AB be the line segment and MON be the perpendicular bisector of AB. Line segment AB is symmetrical about its perpendicular bisector MON. Angle. An angle with equal arms has bisector of the angle as line of symmetry. Angle AOB is symmetrical about its bisector OC. Kite. A kite has one line of symmetry, which is the longer diagonal, as shown by dotted line in the figure. PQRS is a kite in which PQ is equal to PS and QR is equal to SR. If we fold the kite along the line PR, we find that the two parts coincide with each other. Hence, kite PQRS is symmetrical about the longer diagonal PR. Isosceles triangle. An isosceles triangle is symmetrical about the bisector of the angle included between the equal sides. Let triangle ABC be an isosceles triangle having AB equal to AC. Draw bisector of angle BAC meeting side BC at D. When triangle ABC is folded along AD, then triangle ABD coincides with triangle ACD. Hence, AD is the line of symmetry of isosceles triangle. Equilateral triangle. An equilateral triangle is symmetrical about each one of the bisectors of its interior angles. In triangle ABC, sides AB equal to BC equal to CA, BE, AD, and CF are the bisectors of angle B, angle A, and angle C respectively. The equilateral triangle ABC is symmetrical to BE, CF, and AD. Thus, It has 3 lines of symmetry. Scalene triangle. Triangle ABC is scalene triangle in which all 3 sides are of different lengths. It has no line of symmetry. Rectangle. A rectangle has 2 lines of symmetry, each one of which is the line joining the midpoints of opposite sides. In the adjacent figure, ABCD is a rectangle. P and Q are midpoints of opposite sides AB and DC respectively. The rectangle is symmetrical about line joining P and Q. Similarly, it is symmetrical about line joining R and S. Remark: the rectangle is not symmetrical about any of its diagonals. Square. A square has 4 lines of symmetry, which are 2 diagonals and lines joining midpoints of opposite sides. In the adjacent figure, square ABCD is symmetrical about lines BD, AC, EF and GH. Rhombus. A rhombus is symmetrical about each one of its diagonals. In the adjacent figure, ABCD is a rhombus. It has 2 lines of symmetry, AC and BD diagonals. Parallelogram. A parallelogram has no line of symmetry. Circle. A circle is symmetrical about each of its diameters. In a circle, infinite number of diameters can be drawn. So, a circle has infinite number of lines of symmetry. Semicircle. A semicircle has 1 line of symmetry which is perpendicular bisector of the diameter. In the adjacent figure, semicircle APB is symmetrical about line PQ. Regular pentagon. A regular pentagon has 5 lines of symmetry, which are 5 perpendiculars from the vertices to respective opposite sides. In the adjacent figure, AR, BS, CT, DP, EQ are lines of symmetry. Regular hexagon. A regular hexagon has 6 lines of symmetry. 3 along the line joining the midpoints of opposite sides and 3 along the diagonals. In the adjacent figure, AD, PS, BE, QT, CF, RU are 6 lines of symmetry. A regular polygon of n sides has n lines of symmetry. Symmetry of English alphabet. Each of the following letters of the English alphabet is symmetrical about the dotted lines as shown below. A, B, C, D, E, H, I, M, O, T, U, V, W, X, Y,